Now it is. So they're gonna, whoever watches this is gonna jump in right here. Okay, so when this was tripled, this was tripled. When this was doubled, this was also doubled. So what kind of a relationship is that? If you double one, you double the other, triple one, triple the other.
Is it directly proportional?
It is directly proportional. Okay, so it's directly, very good. And if it's directly proportional, what exponent do we use in our rate law or A? So in our rate law where we have R equals K, A, and the other one is B, right? Yeah, B. So what number goes right here?
3 or 2.
Would it be 1?
It would be a 1, right? Directly proportional is a 1. I don't have to write a 1 there. I could just leave it off. But sometimes, maybe at this point, writing a 1 there might remind us that we actually did this. We do know what we're talking about. That is directly proportional. Is somebody asking a question that I'm not hearing? Nope. Okay. So are we good with number 2?
Yes.
Yes.
Okay. So now, on this one, we had to make sure that B was constant. For this next one, I need to make sure that what is constant?
A.
You need to have A constant. And which ones can I pick for that? So we'll have to go back
2, 4, and 5.
and use 2. Yeah, 2, 4, and 5, okay? Okay. And again, we're just going to do the same thing with the concentration on the top. This time it's going to be B over the concentration of B in another trial. And we always want to have what on top again?
Larger
Bigger number.
The biggest number. So which of 2, 4, and 5 do we have the biggest number for on the top, I guess?
5.
Can you scoot the paper up a little bit?
Okay. I guess you can look at your own data table. Okay, so I could pick either, I can do one over here, I can do another one over here, and we should get the same answer. Or the same relationship, I should say. So over here, I could take what over what? Which one over which one?
5 over 2.
Okay, I could take a 5 over 2. Or I could take a what?
4 over 2.
We could have taken a 4 over 2. Now you could actually take like a 5 over a 4, but then you'd end up with a decimal number. And you're kind of getting into fractions again. Okay, so why don't somebody, one of you do this one and some of you do this one and see where we get on that.
First one's 3.
We're taking the concentrations of B on the 5th trial or the concentrations of B for the 2nd trial or experiment, I guess is what they call it.
The 5 over 2 is 3.
This one comes out to 3.
Mm-hmm.
And what does 4 over 2 come out to?
Probably 2.
It does come out to 2.
And this one comes out to 2, okay? Now so that takes care of our concentration part. So now we need to do the part with the rate. So this is the R over R. In both of these. And which R over which R over on this side? Am I up high enough?
Yes.
Okay. Which
So
R over
R5 and R2.
5 over 2 over here? And over here, this would be
R4 and R2.
4 over 2. Okay. So if we take the rate at 5 over the rate at 2, we get what?
About 9.
9, yeah.
About 9. Okay. That's good. What about this one?
I got 4 exactly.
Oh, 4 exactly. Good. Okay, so what appears to be happening here? Okay, when this was tripled, when I tripled the concentration of B without changing A, the rate went 9 times as much.
Mm-hmm.
So what do you do to 3 to get 9?
Square it.
Square.
Okay, so if I square that, this one looks like a square here. What do I do to 2 to get a 4?
Square or
Here.
or multiply.
On all of these, probably the thing I should make sure that you're thinking is always think of what exponent would make this happen. Not, I'm not multiplying by 2, even though that's what I do when I square it, I'm taking 2 times 2, but you guys are farther in math than that. You know what square means. Okay, so this is also a square. So in my, let's see, right up here, in this reaction rate that we have to this point, what are we going to put over here after B?
2.
We're going to put a 2, right? Yeah, and if you're showing your work as you do this, this will really help you when you have to take your data from the actual lab, and you'll know what to do. I'm just going to follow the same steps. Okay, so that takes care of what, 3?
Yes.
All we have left is the easy stuff.
Dang.
Okay, I'm going to have to move that out of the way. So, okay, so on number 3, it says determine the no, we did that one. On number 4, calculate the overall order of the reaction. So how do we get the overall order? Anybody remember that? We add the exponents. And what are our exponents?
1 and 2.
1 and 2. So we come up with a
3.
3. Okay, so your overall reaction order is a 3. Very good.
Oh.
Get to use your first grade math,
Ooh, I passed that one.
just in case it was getting rusty.
Yeah.
Now, determine the rate law. We already did that way up here. Oh, maybe off the screen again. We already did that.
Oh,
Do we just write that in there?
You just write that down there. Yeah, that's all you have to do.
no way. This is-
Yes way.
Wait, what are we writing?
The R equals da 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 da. Da.
Now, this one I have up here in the box, we actually created the rate law as we were going.
Gotcha.
Now, only because I knew where we were going, you may not have thought about that. You just knew up here maybe that A was going to have a 1 after it. Down here, a B was going to have a 2 after it. And then to write the whole law, we would have to, well, we always begin with R, N equals K. and then we just take our pieces over here and build it. If you don't want to put that 1 there, I mean, usually we leave it off, but if you want to leave it there, I'm fine with that. Okay, number 6 is our last thing that we have to do. And we need to find out what are the units for K. Okay, so if I was to solve this equation for K, I would have to divide both sides by A to the first power and B to the second power. I have to divide both sides by that to get rid of it, right?
Yes.
So I end up with K is equal to R on the top over A and B squared. Okay. So I'm just turning this around so I know where to put my units. Now, all we're doing is, all they want you to find out in this one is the units. They aren't asking you to find out what the number is actually. So we're just looking at units right now. So what's the unit for R?
Seconds.
It's seconds -1, so that means it's where, really?
In the denominator?
It's in the denominator, so I'll put a seconds down here. And what is the unit for, or the concentration of a unit? It's always given after each number in the concentrations for A.
It's
Molar?
Molar.
Yeah, it's molar, right? So we put an M down here. I'll put a dot here because mean that we're multiplying it there by molar. And this is to the first power, so I don't have to do anything with that M. It's just M. M to the first power is M. What am I going to put down here, do you think, for B?
M again.
Squared?
Yeah, M squared, right. I hear the squared. That's
Yeah.
another M, but this says I should square it, so I'm gonna have M squared. Doesn't look like there's anything on top other than a 1. So now let's go over here. So I have seconds, and then I have M to the 3rd, right?
Yeah.
Yep.
Yes.
Okay, now what they want you to do when they ask for the units, not write it in a fraction form, write it so that there are no fractions. How would I write the seconds so there isn't in the denominator?
The -1, negative
Okay, I'm gonna have a second -1,
times.
and I'm gonna write this as what? Get a chance to
M to the -3.
M to the -3, way to go. Okay, that's your units. Now, had they asked you to find out the number for this, and I can't remember if in the real lab you have to figure out the number or not, but you just put numbers in here. It'd be the, and you do it for one experiment. In other words, just down one row. You don't change to anything else like we did up here on the top. So if you were to figure this out for, if they wanted to do the numbers. So this would be like bonus here. They're not asking for it. But on top, I would have, let's take the first row. I'd have 0.0067. And then the concentration of A is 0.10 M. And the other one is 0.05 M squared. So I'd just take the 0.0067, divide it by 0.1, and then divide it by 0.05 squared. And I'd have the number.
Cool.
And we already know, I guess this one is seconds -1, but we're not dealing with the units right now. We're just looking for the number part. Anybody calculate that just out of curiosity?
I got it.
And you got
28.
28. And it would be 28 molar, 28 per molar cubes seconds. That's what would the units would be.
I got,
Somebody got different than 28?
yeah, I got 26.8.
26.8. And
So I guess it's,
did you use the first try or what I have written here?
yeah.
Okay.
Let me double check that.
It's so close. I'm curious why we're so close, but not exactly the same. If
I
you,
don't know. I could be wrong. Yeah, I did it again and still only got 26.8.
I think it's because I used 0.07.
oh, you use, okay, that would make the difference. Yep. So, any questions about this?
Nope.
So the only thing I didn't cover in the PowerPoint lecture was the very first step of how do you change reaction times into reaction rate. That's the only thing that's brand new. Otherwise, the rest of it is what we covered in that lecture. So anything else?
We just turn in this page 5 to you.
Yeah, that's all you have to do is just scan page 5 and turn it in and you're done with the pre-lab.
Yay. And did you post the lab that's due Monday?
Yeah, some of you were running into issues and I couldn't figure out why. And some of the questions were just confusing to me because I was assuming one thing that turns out not to be true. What I had put up there is the video portion of the lab where I'm demonstrating this for you. The part you didn't get was the actual paper lab where you're going to record your data and follow along with my steps and stuff like that. So, so you have to download that too. So sometime, I don't know, I think it was this afternoon. Can't remember when I did that, or was it late morning, one of the two, but enough of you had asked questions and I couldn't understand your questions because I was assuming something be true that wasn't. So, and I think some of you are saying you can't find a place to record your data. I think, William, you said you couldn't find a place, and that's because you didn't have the right form or the right lab.
Yeah, I couldn't have the right sheet thing. The one that you added in.
Yeah, the one I added, and I think it actually says page 9 on the bottom.
Yep.
Okay, so all I wanted you to do today is just watch that video and get your times. I think it's a total of what, 12 different times? You do 3, 3, and for one, in other words, you're doing 3 different things, concentrations, and then you repeat that. Then you do 3 concentrations for the other chemical and repeat it. So that's 3, that'd be 12 times. You're just watching it and writing down the times. Use your cell phone as a stopwatch. And you get to decide when you can't see it anymore. As long as your level of visibility is the same in every one of these, you'll do fine.
Okay.
And then tomorrow we don't have any assignments because it's walkathon day.
Yay.
my wife and I will probably walk, but not, not there. We live right behind Lewis and Clark Middle School, and they have this awesome track. Man, it is one nice looking track. And we walk on there every day, so we'll get our miles in up there. But we do that every day, so it's not gonna be any different. But then on Monday, your assignment will be to just finish the calculation part of the lab, sort of like what you're doing like we did this evening here. We're just gonna do that part. It does add one other thing that you have to do is create a graph, and I didn't want you to bog down on making your graph. In other words, creating the graph. So I created the graph for you, and you just have to plot the points and figure out what the pattern is from that. And so on that lab, you only turn in, I think there's 3 pages. The data table, the question, like this one had questions, and then you'll have that graph. So any questions? Anything else?
I'm good.
Well, then I hope you all have a good walkathon and weekend. I think we're all getting closer to the time when we can actually have a little more freedom.
Yeah.
Someday.
Amazing how different people have responded to this circumstances. Some are almost on the paranoid side, I would say. And other people have thrown caution to the wind, let's say it that way. You have a whole extreme on that. I'm probably somewhere in the middle. What was it, last Saturday? We went to the Menards on 72nd Street by I-80.
Mhm.
And there were so many people in that store. I don't think there's ever that many people in the store unless it's Christmas. And hardly anybody was wearing a mask, and they were not standing a full 6 feet away from each other. And they weren't controlling how many people were in the store or anything.
Oh, wow.
Then we went to to Lowe's over here by Chick-fil-A, and they were only letting in a few people at a time. So you see, even stores don't even do the same thing.
Yeah.
So stay healthy. Don't do anything stupid.
I can try.
In other words, don't go around licking the floor. I don't know if I ever told you that story about
No, no.
What?
a boy who when I taught at Kansas City Christian, there was some students were daring this one boy who would always take a dare for almost anything, as long as you would give him something he thought worthwhile. So I think at that time, this has been quite a few years ago, they actually came up with like $20. We dare you to lick the hallway floor from
No.
Ew.
to the other end of the building.
Oh, no.
And it would have been at the La Platte campus, it would have been probably like half again as long,
Oh, mm-mm.
okay? But not carpet. It was floor. And he did it from one end to the other end.
That's so gross.
And when he got to the other end, you know how all the hair and stuff that's on the
Oh,
That's the humor.
his whole tongue was pretty hairy. Now he got his $20, and then he got sicker than a dog. He missed
Oh,
school.
stop.
bet.
That's so gross.
He picked up sufficient germs to. He was sick.
Oh, no.
He just totally overwhelmed his immunity.
He's lying to you. It was actually William.
No, I've only had one person that was, I would say that was stupid, yes.
A little.
Yeah. So, yeah, as long as you don't do anything like that, I think you're probably going to be good.
Okay.
Okay. We'll see ya.
Thanks, Mr. Huber.
Thank
You're
you.
welcome.
Thank you.
Bye-bye.
Bye.
Bye.